Alright, we'll go over 11.3 now. And at the beginning of the section on page 781, we have these rules you can follow, or guidelines, I should say, where when we're solving equations using quadratic methods, we have choices that we can use. And number one, if the equation is in the form of ax plus b squared, and it's something raised to the second power, of course, or any even power, I may add, equals the constant, then we can use the square root property. Okay, number two is write the equation in standard form and set it equal to 0. So if you get, you can do it with the binomial here squared. Nothing wrong with that, but it's just a little bit more work doing that. But any other equation that's quadratic, meaning something that is x to the second power, we want to get it equal to 0. Number three, try to solve by general factoring that we learned in chapter 6. Lots of times you can just factor it the way we know, depending on if the lead coefficient is 1 or not 1. And number 4 here, it is solve the equation by completing the square or the quadratic formula, which you can solve any quadratic equation by completing the square or using the quadratic formula. So as these guidelines, you can go ahead and we're going to go ahead, or I'm going to go ahead and do the examples similar that we did in class. Not the exact same ones, but some that are similar. And we'll talk you through it as we go. Okay. Okay, here is practice problem 1 from our textbook on page 781. And as I'm analyzing this problem, I see I've got a radical in this problem. So what I want to do in terms of solving it is I want to isolate the radical. And how do I do that? I'm going to do that in this problem by, I'm going to add the square root of x minus 1 to both sides, thereby getting this to be positive on the right side. So if I add the square root of x minus 1 to both sides, okay, then I end up with this x minus 3 that equals the square root x minus 1. Okay, now I'm going to square both sides. My right side is just going to be x minus 1. And my left side, now I've got to multiply this together. I have to multiply this together. So this is going to be, let's see, I'm going to take the first term and square it. I'm going to multiply these three numbers together, and that's going to give me negative 6x. And my last term here, negative 3, I'm going to square that to give me positive 9. So if you want to go ahead and FOIL that, I know we spoke about that in class, by breaking it up and FOILing it, by all means go ahead. But I hope you pick up on this idea of factoring. It's a little faster. Okay, now I'm at this point, and now I've got to get this quadratic equation. This tells me it's quadratic, the raised to the second power. And so that means I got to get it equal to 0. So now I'm going to subtract x and add 1 to both sides. Subtract x and add 1. Doing it all at one time. And then I've got x squared minus 7x plus 10 equals 0. Okay. And now I'm going to factor this. And we've seen this many times before. X, copy down this sign here to make for my minus. And if this is positive and this is negative, this has to be negative. And my two numbers for 10 are going to be 5 and 2. Therefore, x equals 5 or x equals 2. Okay, so that worked out nicely. It wasn't too hard, but we recognize at the beginning of the problem I got a square root in it. So therefore, if I have a square root in it, then I want to isolate it, then I'm going to be able to square it. Okay? And just for the heck of it, let's check this answer, by the way, which I told you about in class. So if I had, what was the problem? X minus the square root of x minus 1 minus 3. Does that equal 0 when I plug in these values here? So if x is 5, this first one would be 5 minus the square root of 5 minus 1. 5 minus 1 is 4. Square root of 4 is 2. And then minus 3. That equals 0. So that's a check. That works. And the other number, 2 for x, then I'll do it here. It's going to be 2 minus 1 is 1. The square root of 1 is 1. And then I got minus 3. Does that equal 0? Well, I got 2 minus 1 is 1. 1 minus 3 is negative 2. So therefore, that does not check. So I only have one answer there, which is going to be x equals 5. So we'll be a little more stringent on that when we're doing these problems. We have to check our answer, and I'll remind you of that as well. Okay? All right, next problem. Okay, the next problem is a pretty huge problem. Fairly huge, but I see I've got fractions in this problem, and as always, when I have an equation that I have to solve for and it has fractions in it, I'm thinking I want to clear the problem of the fractions, and I'm going to go ahead and do so here by multiplying each of these terms by the LCD. And the LCD in this problem is going to be this x times x minus 1. Okay, so that's going to be, if I'm going to multiply this by x times x minus 1, I'll do it up here. It's x times x minus 1. X times x minus 1. And this one, x times x minus 1. All three of them. Okay, what I like to do is box them so I can see inside the box what needs to be simplified without being distracted as to what's next to me. So in this case here, I've got x times x minus 1 divided by x minus 1. I want to do the simplifying first, then multiply my numerator to whatever's left over in my simplification. So here I've got x minus 1's. You know, this is really in the numerator, right? And this is the denominator. So here I'm crossing them off. They become 1's. And I've got left is x. And I'm going to multiply the x times the 2x now. So that gives me 2x squared. Here I got a minus sign. So I've got a little bit of work to do here. So this is always a little problematic, a minus sign in front of a term. And in this process here, I've got x's here that are the same, so I can cross and cancel these out. And then notice I've got x minus 1 times x plus 2. Now I'm going to have to multiply that together. So I'll do it over here. X minus 1 times x plus 2. No shortcut here because they're different binomials. Only when the binomials are the same can I do the shortcut method. All right, so nevertheless, I've got x squared plus 2x minus 1x minus 2. And that's going to give me x squared plus x minus 2. Okay, I can put that down now, or I can remember that this is, I'm subtracting this minus sign here. This is subtracting this trinomial now. So I'm going to subtract it out here in my work area, and I'm going to put in my results here. So it's going to be negative 1 times x squared is negative x squared. Negative 1 times x is negative x. And negative 1 times negative 2 is positive 2. Okay, and now at this point I can combine my like terms. I can if I want, or I can wait till I do the third box there. As a matter of fact, let's do the third box. Okay, so this is my simplification of box 2, and this is going to equal, well, this is easy. The x times x minus 1 over x times x minus 1, those just cancel out, and I get a 5 left over. All right, so now I'll go back. I'll combine my like terms. Here I'm going to have 2x squared minus x squared is x squared minus x plus 2 equals 5. Here's my quadratic equation indicator, the x to the second power, which means I have to get the equation equal to 0. So I'm going to subtract 5 from both sides, as such. And I've got x squared minus x minus 3 equals 0. Okay, and what have I got here? Oh, I've got something that's not factorable. Okay, so that means I've got to do another method. I could use the quadratic formula, or I could do completing the square. Whatever is your favorite. So let's see, I'm going to complete the square on this one. And I'm going to do that by writing x squared minus x plus something that equals 3. Remember, I add 3 to both sides to bring it over to the right side. I clear out the C spot on the left side, and I determine what number goes there. So let's see, I've got a 1 here in the middle, and if I square it, if I divide it by 2 and then square it, I'm going to have 1/4 that goes over here. I'm going to add 1/4 to the left side as well as add 1/4 to the right side. Okay. And then I'm going to go ahead and factor this left side. So here's my factorization on the left side. It's going to be x, x, minus, minus. And my two numbers that go here in the last of the foiling method is the 1/2. 1/2 and 1/2. And that's going to equal this 3/4, 3 plus 1/4. And I'm going to write that up as, well, this equals 3 1/4. And I can write it up as a improper fraction. So that would be 12 plus 1 is 13 over 4. Now I'm going to take, at this point, I'm going to take the square root of both sides. Remember, I do these separately. And then I've got my left side is going to be x minus 1/2. That equals the square root of 13, plus and minus the square root of 13, over the square root of 4, which is 2. Need a little more room because I'm almost done. I just have to add the 1/2 to both sides. Let's see, I'll go x, this is 0, equals, adding my 1/2 now. I want to put that in front of the plus minus sign. Plus or minus square root of 13 over 2. And that's my solution there. Okie doke. Tough problem. And I will not have you check your answer for this one. This is kind of, it's a little tougher to do that. So not this type of problem. All right, let's move on to another example, practice problem 3. Okay, in practice problem 3, I see I have a quadratic to the 4th degree. All right, well, that's fine as long as this first term is an even degree, even exponent, because that means I can split it up because I'm factoring. So when I do this, I've got 2 sets of parentheses and make a note here that my lead coefficient is still 1, so this is still translating to be the easy method for us. And then I know that my first terms here are going to be x squared instead of x. We always used to put x most of the time, but now it's x squared because of the obvious. And I'm still going to follow suit with following my sign. So if this sign here, remember I copy that sign, that's minus. And if this is negative and this is negative, that means this one here is positive. And now my number here is 36. And I need two numbers that multiply to be 36 and subtract to be 5. And I'm thinking 9 and 4. I'll put the larger number first, and then the 4 second. And as I move on, I'm reminded that x to the 4th, that tells me I could have up to 4 answers. And I recognize this x squared minus 9 as being a difference of 2 squares, so I can factor that to be x minus 3 times x plus 3. Okay, and then this binomial here now I can still factor because I've got the square root property, and I've got, even though it'll be negative under the radical sign, it's okay because I know I've got the I that I can factor with. So in this one here, if I've got x squared plus 4 equals 0, I'm going to subtract 4 first. And I've got x squared equals negative 4. Then if I take the square root of this, taking the square root of both sides, now I see I've got x equals plus or minus the square root of negative 1 here is the I. I'll put it over here because I see what's coming. And then the square root of 4 is 2. So I got x equals plus or minus 2i. And that gives me 2 answers. Here's the third answer, and here's the fourth answer. And that's what I've got. Our next problem, one of my favorites, is using substitution when I have a problem like this. I could go ahead and FOIL this out, this binomial to the second power, and then combine all my like terms to get another trinomial. Or I can use what's called substitution. So that means if I look at my middle term here, b, I could say that I could use b if I want, but in our book and in coming math classes that you go on to, we traditionally use u. Okay, so I could say u equals this x plus 4. Okay, so if u equals x plus 4, I could rewrite this equation to be u squared minus u minus 6 equals 0. And now I got a cleaner looking problem here, and something that we are real familiar with when we're factoring. Okay, so I know this is the easy one. So I'll set my parentheses up. U is going to go here and here. My signs are negative and positive. And my two numbers that I'm going to use are going to be, looks like 6 and 1, right? 6. No, I need a negative 1 here. So it's not going to be 6. It's going to be 3. So let me get my eraser out here. Erase that. And replace it with a, let me replace it with a 3. Because my numbers are going to be 3 and 2. Okay, so now I've got that this one is that u equals 3 to make that 0. And this binomial here, u would equal -2 to make that equal to 0. But as in we did this in class, remember, u equaled the x plus 4. So I got to substitute the x plus 4 for the u here. And that'll give me x plus 4 equals 3 that I have to solve for x. Because that's really what the problem is. What is the replacement value for x in the original problem? Okay, so here I'm going to subtract 4 from both sides. So I know this x is going to equal -1. And then for this u, I'll replace the x plus 4. Same x plus 4, because that's what u equals. X plus 4 equals -2. And then I can see that I'm going to subtract 4 from both sides, and x will equal -6. And those are my two values here. -1, -6. And that is the answer to practice problem 4. Okay, here in practice problem 5, I could use u substitution as well, which I'm going to do in this problem for us. I'd like you to know how to do this and do it well. So because this is quadratic in form, you know, I could really rewrite this as x to the 1/3 power and then raise that to a second power. So it's an equivalent expression, and then minus the 7x to the 1/3 plus the 10 equals 0. So now over here I could say, I'll do it up here, that u equals x to the 1/3, which you can see it clearly here. I've got an x to the 1/3 here and an x to the 1/3 here, so I'm going to make that u equals x to the 1/3. And the trick in these is to make u equal this middle term, part of b, the variable part, not the coefficient that goes with it. All right, when I rewrite this problem now, it's going to be, since u equals x to the 1/3, it's going to be u squared minus 7u plus 10. That equals 0. And now I'll go ahead and factor this. And isn't it wonderful when you do enough of these problems, you remember what the factorization is? I hope that's happened to you. At the end, well, now that we're at the end of intermediate algebra. So here I've got u, minus, minus, and my two values are going to be what? 5 and 2. Okay, so for this binomial, u is going to equal 5. And for this binomial, u will equal 2. But this isn't my answer. I've got to substitute the value of u, which was that u equals x to the 1/3. So I'm going to put x to the 1/3 equals 5, and x to the 1/3 equals 2. And now I want to isolate my x here on the left side here. So that means I have to multiply both sides by 3 to the power of 3. Okay, so x to the 1/3 raised to the third power rule will make this left side just equal x, and the right side will be 125. That's what 5 to the third power is. And the right side as well, I'm going to raise both sides to the third power. And the left side here is going to be x. That equals 2 to the third, which is 8. And there are my two solutions for that problem. All right, one more problem. And it's the story problem.